Welcome again to Math 800 Pre-Algebra. Today we are doing section 2.2, Simplifying Expressions. Our objectives: 1. To combine like terms using the distributive property. 2. To simplify expressions. And 3. To use the distributive property to multiply. Objective 1. Combine like terms using the distributive property. The basic idea in simplifying expressions is to combine or add like terms. Each addend in an expression is a term. Please note, addend means things that are being added. When we get into addition with negatives, recall that adding a negative is the same as subtracting. So technically, an addend is any addition or any subtraction. Here is an expression. It has two terms, and it is separated by a plus sign, or an addition. So this addition separates the terms. C is one term, 5 is the second term. We call terms that don't have variables constants. So this is a variable term, this is a constant term. Here's another example. This has three terms. There are three things being separated by additions. 6x squared is a term, negative 2xy is a term, and 8 is a term. They are separated by additions. Please note that adding negative 2xy could be written as just subtracting 2xy. This also has three terms, the 6x squared, and we consider this a negative 2xy. In math, as you move on, when you see something like this, your teachers will refer to this as a negative 2xy because really, we're adding a negative 2xy. And then the 8 is the constant term. A variable term has a number part, which is a coefficient, and a letter part, which is the variable. Here is a variable term. This is a single term. The reason this is a single term is because you are multiplying the 6 and the x squared. There is no plus sign. The 6 is considered the coefficient. The x squared is the variable part. Here is another term. Again, this is one term. It has a single coefficient of negative 2, and the variable part is xy. There is only one coefficient, just this number up here. This is only one term. A single variable, such as c, could be written as 1c. Remember, when you multiply by 1, you don't change anything. So 1 times c is the same as just saying c. Therefore, a variable with no coefficient written is understood to have a coefficient of 1. So again, as you move up in mathematics, anytime you see a single letter, there is an understood coefficient of 1. Some teachers and books write it, and some do not. Please note the difference between coefficients and constant terms. Here we have a single term. The negative 2 is the coefficient of this single term. Here we have three terms. Negative 2 is a constant term, and then the x, which would have a coefficient of 1, and the y squared, which would have a coefficient of 1. Here, there's only one coefficient, and it's negative 2. Notice the difference is the operation. In the top one, these three things are being multiplied. These are all factors in a single term. Here, these three things are being added. These are all addends, and they are three terms. Again, the difference is the operation. Like terms. Like terms are terms with exactly the same variable parts. They have the same letters and the same exponents. The coefficients do not have to match. So like terms are the variable parts, so the letters and the exponents on the letters. Here are two examples of like terms. 5x and 3x. The variables match, they're both x's. And negative 6y cubed and y cubed. These are like terms. They both have y cubed. These are unlike terms. Here they have the same letters, but different exponents. This has an exponent of 1, or no exponent. This is an exponent of 2. So these are unlike terms. Here we have different letters. List like terms in the expression. Identify the coefficients of the like terms. We have 1, 2, 3, 4, 5 terms. Remember, terms are separated by additions. So there's 5 terms. Like terms have the same variable part. Negative 5x and x are the like terms. This is a constant term. There is no variable. There are no other constants. This has an x and a y. Nothing else has an x and a y. And this is an exponent of 2. This is x squared. Nothing else has an exponent of 2. So only negative 5x and x are the like terms. The coefficient of negative 5x is negative 5. The coefficient of x is 1. Recall that you can multiply anything by 1 and it doesn't change anything. So the coefficient is negative 5 and the coefficient is 1. Another example. Here we again have 1, 2, 3, 4, 5 terms. They are separated by additions. In this case, the like terms are the constants, the negative 6 and the 12. They have no variable term. This has two letters, A and B. Nothing else has two letters. This is a single A, but nothing else has a single A. And this is a single B, but nothing else has a single B. So only 12 and negative 6 are like terms. Again, there is no variable component to the like terms. The terms with variables do not have identical variable parts, so they are not like terms. The distributive property can be used in reverse to combine like terms. This expression, 3x plus 4x, can be written as parenthesis 3 plus 4 parenthesis x. You are undistributing the x. You're taking back this x. Remember, when you have 3x, this means 3 times x, and this means 4 times x. So you're just undistributing the multiplication. Typically, you used to see it written in front of the parentheses, but remember the commutative property tells us that it doesn't matter what order things are multiplied in. So in this case, we are choosing to write the x afterwards. We can use this idea to simplify. Now that we've removed the x, we can add 3 plus 4 and get 7x. Therefore, 3x plus 4x is 7x. In the next few examples, we will continue to use this process. However, in your homework, on your quizzes, and on your test, I do not expect you to go through this process. Hopefully, you will be able to see 3x plus 4x and realize it is the same as 7x. Please be careful. Notice the x stayed an x. It did not become x squared. Think of it in some cases like a unit. If you have 3 inches of something and you add 4 inches, you have 7 inches. You do not suddenly have 7 inches squared. So when you add, the variable part stays the same. Now we will go through the steps for combining like terms. First, if there are any variable terms with no coefficient, write in the understood 1. Again, some of you will need to do this and some of you will be able to do these problems without doing step 1. Step 2, if there are any subtractions, change each one to adding the opposite. Again, some of you still need to do this step, and some of you are able to complete this without doing this step. Step 3, find the like terms. The variable parts match. I personally find it helpful to underline like terms. So I will underline the first set of like terms with a single line. If there is a second pair of like terms, I will use a double line, and so forth. And lastly, add the coefficients. That's the number part of the like terms, and the variable part stays the same. Notice that this is in bold and italicized. This is very important, and many students make mistakes with that. An example. Combine like terms. Negative 3y squared minus 8y squared. Both the coefficients are shown, so we don't have to write in anything. Next, we will change the subtraction to adding the opposite. Again, some of you need to do this step, but some of you do not. The like terms, there are only 2 terms, and they are like terms, are the negative 3y squared and the negative 8y squared. They are like terms because they both have a y and they both have an exponent of 2. We will add the coefficients negative 3 plus negative 8. Again, think about this like doing the distributive property backwards. You're undistributing the y squared, and then you're adding negative 3 plus negative 8 is negative 11y squared. The goal is for you to look at this expression and just know it is a negative 11y squared without having to go off through these steps. At this stage, if you need to write these steps down, that's fine, but the goal is just to know, oh, this is negative 11y squared. Another example. Simplify by combining like terms. Again, we are only combining the like terms. So 6xy and 3xy are the like terms. 2y, this term does not have an x, so it cannot be combined. We will add the coefficients, 6 plus 3. The xy will stay xy. So 6 plus 3 is 9. And then we have the plus 2y. You have to keep the 2y in the expression. Even though it couldn't combine, doesn't mean you can't use it. So here we have our final answer, 9xy plus 2y. Now we will simplify 5 parenthesis 10y parenthesis. Remember that there are several multiplications we simply don't write in. There's a multiplication outside the parenthesis, and there's a multiplication between the 10 and the y. The associative property tells us that when we're multiplying, it does not matter which ones we do first. So we can choose to do the 5 and the 10 first. 5 times 10 would be 50y. Therefore, 5 parenthesis 10y is the same as just saying 50y. Again, I do not expect you to go through these steps. This is just illustrating why this process works. Simplify. -4 parenthesis -2 x squared parenthesis. We will use the same property, the associative property. That means we can group these and do the -4 times the -2 first, and that gets us 8x squared. Notice the x squared just kind of tags along. Now we will use the distributive property. We have the 6, and we are going to distribute it to both parts of the parentheses. So 6 times y minus 4 can be written as 6 times y minus 6 times 4. People often forget to take the 6 and multiply it by the second term in the parentheses. Notice the subtraction just says a subtraction. Therefore, 6 parenthesis y minus 4 simplifies to 6y minus 24. Many people write in the arrows to remind themselves to multiply both terms in the parentheses. I personally write an arrow on top and the second arrow also on top. Simplify -2 parenthesis 4a plus 3. We will distribute the -2 times the 4a plus the -2 times the 3. The associative property says that we can do this multiplication in any order, so we get -8 times a plus -6. Please note, you can rewrite it as a subtract 6. At this stage, I will accept both answers. They are correct. However, as you move up in mathematics, your teachers and your books will prefer you simplify the adding a negative to subtracting. So most books and most teachers prefer this answer. And again, you can write it with the arrows very quickly. -2 times 4a is -8a. -2 times 3 is -6. And it is understood that a -6 is the same as, or adding a -6 is the same as simply subtracting 6. Simplify. 8 plus 3 parenthesis x minus 2. Remember from order of operations that this multiplication, that's between the 3 and the parentheses here, must happen before you add. So first you need to distribute the 3. Again, do not add the 8 plus 3. Order of operations says multiply first. So distribute the 3. In this case, we will just rewrite this as 3x and do this multiplication. So you have 8 plus 3x minus 6. Now you can rewrite it if you need to get like terms next to each other. Again, some people need to rewrite it, and some people do not. We're going to rewrite it so the 3x is in front and the 8 and the -6 are next to each other. Be careful when you're rewriting with the negatives. This was adding a -6, so that negative or the subtraction has to stay with the 6. When you move the 3x, it doesn't move with it. This belongs to the number behind it. 8 minus 6 is 2. That concludes section 2.2. Complete worksheet for section 2.2. This is worksheet 10. Make sure to check the key for worksheet 10 in D2L, or if you are in my face-to-face class, please wait until class. We will go over the key together. Then complete the online homework for section 2.2 through My Math Lab, and lastly start on section 2.3.